zeros. I'm sorry, or positive coefficients. 2, 7, 6, and 1 are positive. So I should not try positive number for x because it doesn't matter how positive it is. If I plug in positive value for x, the sum will always give me back a positive number. So I better try a negative number. I'll start with -1. Try x equal to -1. Try x equal to -1. Okay, if it works, awesome. If it doesn't work, try -1/2. Try 1, -1. So I'm going to use synthetic division because if it's 0, then when I do synthetic division, I got remainder equal to 0. Try it. 2, 7, 6, 1. Okay, bring the 2 down. 2 times -1 is -2. Plus 7 is 5. 5 times -1 is -5. Plus 6 is 1. And then 1 times -1 is -1, 0. Bingo. We got remainder equal to 0. Okay? That means the polynomial function f of x, 2x cubed plus 7x squared plus 6x plus 1 can be written as x plus 1 times the quotient right here. And how do you read the quotient? 2x squared plus 5x plus 1. X plus 1 times 2x squared plus 5x plus 1. You see that we already factor polynomial degree 3 out into product of 2 factors, linear times quadratic. Okay? X equal to -1 is a 0 already. So you got 1, 0 tackled down. You got 2 more to find. And I claim that the 2 other zeros will come from that's quadratic right here. Now you don't need the rational zero test anymore because we mastered quadratic already. We can find other 2 zeros right here by the quadratic formula. And this is a good change to recall the quadratic formula. Quadratic formula. Say what? X equal to -b plus or minus square root of b squared minus 4ac all over 2a. So a is 2, b is 5, and c is 1. So that's what? -5 plus or minus square root of 5 squared, which is 25, minus 4 times 2 times 1. So all over 2 times 2. This is -5 plus or minus square root of 25. This is what? 4 times 2 times 1 is 8. 25 minus 8 is 17. So over 4. So pretty much you got 2 more solutions, and they are not rational. Okay, just irrational number, but that's fine. -5 plus square root of 17 over 4, and the second one is -5 minus square root of 17 over 4. Alright, so you have 3 zeros. This polynomial, you have 3 zeros. The zeros are x equal to -1, x equal to -5 plus square root of 17 over 4. The last one is x equal to -5 minus square root of 17 over 4. They're all real numbers. And you may see a bonus question. It asks you to express the polynomial as product of linear factors. So you're going to write this way. Leading coefficient is 2, right? Product of 3 factors. You're going to have what? So x plus 1. So let's say we got 0 right here, and then x minus fraction -5 plus square root of 17 over 4, and then x minus -5 minus square root of 17 over 4. And of course you can simplify the negative sign, but let me just leave it there. This is the second type of problem you may see. Find all zeros of a polynomial. Okay? So you have a high degree polynomial. The first step that you try to do is use a rational zero test to try our luck to find the first couple rational zeros. And if you're lucky, you'll be able to find one or maybe a couple. And eventually you're going to go down to product of a bunch of linear factors and a quadratic, couple quadratic maybe. And you can use quadratic formula to find any zeros of quadratic. Okay? In this course, in our textbook, I'll read over it, I'll tell you what. You will always be lucky. Means what? They ask you to find rational zero, you will take the last over the first using rational test. Eventually, you'll be able to find the first rational zero. So, for our class, I say that you will always be lucky. But don't think of it that way. If you see it's a random problem out there and you try our luck, it may not work, okay? Life out there may not be that pinky. Alright, and that's the end of section 2.6. This is the biggest section of chapter 2. Hopefully, whatever I covered today is a little bit helpful for your learning. Again, should you have any question, please feel free to ask me. And have a good day.